For this problem, nowhere in here does it say we cannot use a GDC, so I'm going to use my calculator. And I've taken the liberty to enter it into the calculator already. And I'm going to zoom to number 6, which is my standard window. And when I see this, I know I want to go further down. So I want to change this y minimum. Let's change it. And now it's just pretty much guessing. I'm going to change it minus 30. Let me graph it then, and let's see where we are. I'm going to go a little bit further. Let's go further down. Let's change it at minus 35 and see what we have there. Okay, so we see that. We see the whole parabola. Now we want to write down the y-intercept. To do it, I'm going to go second, trace, and ask for the value when x equals, for a y-intercept, x is always equal to 0. And so then I have a, I get the point 0, comma, negative 30. Then it wants me to find the x-intercepts. Well, to do it, if I look at this one, 1, 2, 3, 4, it looks like it's 5. So if I'm going to go to my calculator, I'm going to find, if I think it's actually 5, I'm going to find the value at 5, and it does give me a 0. So that's kind of a shortcut. If you think you actually know it, and if you get a 0 back, then you can guess it. If not, you have to go through the whole process of finding a 0, which I'll do right now. Second, trace, I'm going to do the 0. Number 2, I think it's negative 3, so I'm going to go left of it. That's what the left bound means. I'm going to estimate negative 3. So left of negative 3 is like negative 5. And then right bound, which has to be the right of negative 3, which is 0. And I'm going to guess negative 3, which is indeed the answer. So here are my x-intercepts. So now I have to change it to factored form. To recap, factored form looks like y is equal to a, x minus p, x minus q, where p and q are the x-intercepts. So if I go y is equal to, we'll leave this blank for a moment, x minus 5, opposite sign, and then x minus a negative 3, which is positive 3. So they look opposite signs in here. And now I need the a value. Well, the a value in standard form is the same as the a value in factored form. A is always the same. So here the a value is 2. So this is factored form. D then says, write the equation of the axis of symmetry and find the vertex. Well, right here in the middle is where the axis of symmetry is going to be. And that's going to be halfway between the x-intercepts. So if I take my x-intercept 5, add it to my x-intercept of negative 3, and divide it by 2, that will find me the middle. And so when I do that, 5 minus 3 is 2, I get 1. So it says here at 1 is the axis of symmetry. And so I can say x equals 1 is the axis of symmetry. Hence, then find the vertex. Well, if I take this x value and plug it in, then I can find the vertex. Or I could also go to my calculator and find the minimum. When I find the minimum, I go left bound, right bound, and guess. I get a minimum of 1 comma negative 32. So the vertex is 1 comma negative 32. So now if I want to write in vertex form of the equation, vertex form says y is equal to a x minus h squared plus k. And so I know the vertex is equal to hk. So 1 is h and k is negative 32. So if I plug these values in as y is equal to something, we'll talk about a in a moment, x minus, change of sign, minus 1 squared minus 32. The k stays the same. The a value is the same as what was in factored form and the same as what it was in standard form, which is 2. So here is the vertex form of the equation. If I want to describe the transformations that happened to it, well, there's three things that have happened. This original parabola that would be x squared was shifted over to the right one horizontally, and vertical translation down 32. And it had a vertical stretch by a factor of 2. That is what this says. So the vertex tells us the translations. The a value tells us our vertical stretch. Going to G, I'm going to switch over to red now, to G. 2 t's on the curve, find t. Well, I can just find the value when x is 2. So second trace value, enter, and I get, negative 30. I get 2 comma negative 30. So t is equal to negative 30. The domain and range, well, the domain for parabolas is always real numbers for x, and the range is y is bigger than, that's negative 32, or equal to negative 32. All these y values the parabola will obtain.